Hello and welcome to an unusual video on my channel. Normally, I build something and take you along on the journey so you can see how to make something similar for yourself. This time, I'm reaching out for the help of the big community of smart people out there to help me understand why my board failed and I blew up a lot of chips. I tried to debug it, but what I found doesn't seem to make any sense in the universe as we know it. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. I want to give a quick shout out to my new sponsor, PCBX. It's a circuit board and board assembly company which turns out is right on the mark for me. I saw a post for their Facebook page and was interested in their capabilities, so I joined the group. PCBX isn't as well known as some of the other circuit board companies, but they've got the facilities to compete with up to 8-layer boards, 2-sided SMT assembly, and over 200,000 parts in their catalog. They also offer their own design tool, but can accept native files from KiCad, Altium and Eagle, and of course, standard Gerber files. The interesting thing for me is that they happily support people like me who only need prototypes and low volume orders. Their circuit board prices are about the same or a little cheaper than the others, but they say their board assembly has better quality at a lower price. As a new customer, you have immediate access to great prices and big discount coupons for boards and assembly services. To top off the partnership, I hope to visit their Shanghai factory this winter and make a great video so everybody can see their capabilities. So be sure to check them out the next time you're uploading a board design. To summarize, I was doing an over-the-air firmware update, which is innocuous enough. It got to 67% and stopped, and then repeated attempts failed at 0. I started probing the board and, well, you'll see what happens. In the end, I toasted 2 ESP-32 modules, 2 serial port chips, and 2 voltage regulators. The issue seems to be related to 3 LEDs on the board that are defying the laws of physics. Now I have a limited number of parts left, so I won't be wiring in my 12-volt power supply anymore. I'll depend on the ESP-PROG or the USB-C cable to do the job. Anyway, I'm going to paste in the raw troubleshooting video with my commentary. If you've got some insight into what's happening, please leave a comment in the doodly-doo below. You can refer back to video 1 in the series to see the relevant parts of the schematic. And I can already feel someone typing in a comment saying, "Oh, this is what happens when you let a software guy play with circuit boards and chips." But I'm just trying to do my best here. Okay, let the fun begin. Oh, it looks like it's uploading. Over the air. Don't fail me now. Stuck at 67. Still working. Oh, upload error. And then we'll try yet another upload. Well, the hardware gods have frowned upon me. In the middle of doing that flash update, the board locked up. I came over here and the power supply light was not working. So I thought, okay, maybe the little 12-volt wall wart that I was using, I tried it. In fact, I changed the wire, and it was the 3 volts was actually blinking on and off, which is totally weird. So I thought, okay, maybe the chip is now with the Wi-Fi running, it's drawing more power, and this one can't keep up. So I hooked up a really beefy 12-volt. It's capable of producing 5 amps. But the board's only going to draw when it needs to draw. So I plugged it in, turned it on, and you may be able to see there is now a little ventilation hole in the top of the 3.3 volt power regulator, voltage regulator, when I put the jumper across here to put 12 volts through the system. This thing started pouring out smoke, which is disturbing. I don't know why it would do that. I didn't change anything in the hardware. So it's getting late. I'm gonna just put everything here to bed and sleep on it. I'll replace this in the morning, and we will see what else is happening on this board. It's very strange for that 3.3 volt regulator to just die a horrible death. Okay, folks, I've just gone through quite the existential crisis. As you just saw instantly ago for you, hours and hours ago for me, the board died in the middle of an over-the-air firmware update. And it turns out that when I buzzed the connection between ground and the 3.3 volt power rail, it was a dead short. Something on the board was making an electrical connection between ground and 3.3 volts, and that's never a good thing. And that probably explains why the power supply had a problem and the chip stopped functioning. So I built a list of all the components that touch 3.3 volts because one of these things is now becoming a human jumper to ground. I also inspected the board to see if I had like a chunk of solder or a wire or something, and everything looked clean. So I checked all the capacitors, which act as signal buffers on the power for capacitive coupling of the power supply input pins to all the chips. Then I checked all the resistors that were a pull-up, and I checked the other side of that. None of those were shorted out. And unfortunately, that left me with the integrated circuits. And so I decided, okay, the most likely culprit is the ESP32. It was working hard when I was doing that software update. The Wi-Fi module was working, the flash circuitry was working, and nothing else really had anything going on. So I unsoldered it, and to its credit, it was fine. After I unsoldered it, the bridge was still there. Then I took at first I replaced the 3.3 volt regulator, and that didn't work. I took that out, still shorted. I took out the CAN bus chip, still shorted. And I'm really hunting for things that are easy to remove and put back. I removed this op-amp chip, still no good. Now, the good thing is the USB-C connector does not have a 3.3 volt connection. It's only the USB 5 volts out, and that was not shorted to anything, so I don't have to worry about unsoldering that insanely difficult one. So that left me with the USB UART chip, which I hate so much because it is so small, and it doesn't even have pins that are external to the chip. It's designed to be put on ultra small circuit board products, and it's just got you can't even see it, I can't focus. It's got those tiny pins underneath the chip. So, well, guess what? I unsoldered this and the short went away. So this guy is somehow fried inside and was bridging 3.3 volts to ground. So I'm happy I found the problem. This is going to be a minor pain to solder back in, but I think I've developed enough skill that I can do it. I'll put everything else back on, and we will attempt to continue on with our software journey. Nothing like having a catastrophic hardware failure when you're trying to update the software in your project. Well, maybe I spoke too soon. As soon as I soldered the ESP32 back in, the short came back, and it was not a solder bridge on any of the pins. That was clean. So this module was toast, As I kind of suspected, and maybe as a side effect, it also took out the UART. So let's go in the bin and get another one of these. Okay, you are not going to believe this. After everything was set up, I wired it up to the 12-volt power supply again, and pop! I blew the ESP-32 and the UART instantly. And I just don't get it. I've been doing a lot of, checking voltages and pins around the board, and right now, the 12-volt jumper isn't even in place. It comes into this side, but it doesn't even go out to the voltage regulator. But okay, and this is where I'm going to need the expertise of the Hive cloud of engineers on YouTube. Okay, nothing is active on this board. No, well, that's not true. I do have this pin, which is the voltage sense input to the ESP-32. I divide the 12 volts down to make a safe reading to read that in. Okay, but that's still a safe voltage, 2.6. Everything else, there's nothing here. But the weird thing is, the blinky light, you remember our friend Blinky, it literally comes out of a pin, through a resistor, through an LED to plus 3 or ground. I can't remember. But if I touch this pin, which is not connected to anything right now, I'm getting -4 volts on the input of the resistor, 3.8. The other side of the resistor, -3. That goes to the pin. Okay, I'm going to walk you through the readings right now. The isolated pin of the ESP-32 that's not connected to anything is reading -3.8. Okay? We come into we come out of this pin out to the resistor, -3.7. Other side of the resistor, -3.7. Into the LED, -3.7. The other side of the LED is literally ground. This is the ground pin. If I change this to resistance and beep, this is ground. You got one ohm to ground right here. It's the same. So how can this LED go from 0 volts on one side to now it's -5.3? -5, and it comes in on the pin at -5. I don't get it. How can an LED magically make negative power? It's making its own negative power rail. This has got to be what's blowing up the ESP, which then goes to the UART. But in another funny LED situation, the LED, the two transmit and receive lights, nothing is happening. Nothing is connected to these pins. The chip's not even there. I'm getting 3.7 volts on one LED and 3.5 volts on the other LED. And this side of the LED is 0. The resistor is connected to 3.3 volts, which is now not even functional on the board. There's no 3.3. So if anyone can explain this, I'd love to know. Is it a quirk of how my meter is reading the voltage through a diode? I don't think so. Anyway, I'm going to remove these 3 LEDs and then check the power again. But something clearly happened to this board. I've checked everything, but I'm never going to use this +12 plug again. I'm going to power the board over USB or with the ESP-PROG, and I'm just going to continue writing my software. Well, you're not going to believe this. I took the 12 volt power supply out. I plugged the USB in, right? That's giving my board 5 volts. But if I come back over here to the blinky, it's still giving me some crazy things are happening. Call it minus 3.6. Maybe I'm wiggling the probe. The UR LED pins. 6.7 volts. How does that even happen? The voltage coming in on the USB port is 5.16. How am I getting a larger voltage than exists anywhere else on the board? All right, I just have to post this as a separate video because this is getting too complicated to include in my over-the-air firmware update. All right, type in the comments below. Tell me what I'm doing wrong. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig, for their ongoing support. I see that a whopping 96% of my viewers are not subscribers, so please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks and take care, and I'll see you in the next video.